So this tutorial video is for stellar parallax lab. I'm gonna help you with the preliminary exercise first, and this tutorial will cover this first couple of parts: calculating the angle of a triangle and parallax angle and distance. So I'll create another video to help you with the calibration and measuring the stellar parallax. So let me start with the calculating the angle of a triangle. So to understand the basic concept, you can see here, this is the triangle and this is angle, and this is the perpendicular triangle. So A is so this B is the perpendicular and then A is the base. So tangent A should be equal to B over A. So that's very simple. And then if you want to calculate angle A in degrees, you just get tan inverse B over A. So there is an approximation here that if A is very small, angle A is very small, then you can simply write tan A equals to A, and that's going to give you the angle A should be equals to B over A, and that's going to give you the angle in radians. So basically when you get the angles in radians, you have to convert into degrees if you want to the angle in degrees. So A angle in degrees should be equals to, so whatever angle you have in radians here, multiply by 180 degree over pi. So that's how you convert the radians to degrees. So how would you get the angle A in directly in degrees? Again, if you want the angle A in degrees, angle A should be tan inverse B over A. That's the angle in degrees. So let me summarize here. For angle in radians, you can simply use A equals to B over A, given that A is very small angle. For angle in degrees, then A should be equals to B over A, and you convert that degrees into 180 degree over pi. So if you solve for B, then B should be equals to A times tan A. If you solve for A, then A should be equals to B over tan A. You can do a little bit of algebra here. So for these last two equations, make sure that you put your calculator in the mode that the problem is giving you the angle of. For example, if the problem gives you the angle in radians, put your calculator in radian mode. If your problem gives you the angle in degrees, put your calculator in degree mode, so that you don't make mistakes. So for the last the second part, so if you are given the parallax angle in arcsecond, then you can calculate the distance in parsec. Here distance in parsec should be equal to 1 over parallax angle in arcseconds. Make sure that if they give you the angle in degrees, then you gotta multiply that degree angle by 3600 to get into arcseconds. So that because this input is arcsecond, so you have to convert the angle into arcsecond if it is not in arcsecond. So if you are required to find the distance in light year, or like here, then you use this equation 3.26 over parallax angle in arcsecond. Again, they give you the degree, then just multiply the angle by 3600 to get into arcsecond. So I want to remind you. So if the angle is, if you want the angle in degrees, then angle in arcsecond divided by 3600. But if you want the angle in arcsecond, then angle of degrees multiply by 3600. So here is the equation. So distance in parsec should be equal to 1 over parallax angle in arcsecond. The parallax angle in arcsecond should be equal to 1 over distance in parsec. Similarly, distance in light years should be equal to 3.26 over parallax angle in arcsecond. Parallax angle in arcsecond should be equal to 3.26 over distance in light year. Parallax angle in degree should be equal to parallax angle in arcsecond over 3600. So I'll cover the examples in next video. In previous video, I covered some of the basics. Let's use this example here. For example, calculating the angle of triangle. So they give you the A and the angle in arcseconds. What is the angle in degrees? So that's the question here. So you are given the angle in arcsecond and you have to get the angle in degrees. So how do you get that? Arcseconds to degree, as I told you, you have to divide the angle by 3600. So let me get here. So 105.568 divided by 3600. So that's gonna give me 0.0293. So and then they're asking for B. So how do you get the B? Let me get the example here, the equation here. To get the B, I'm gonna get the A tangent of A. So the angle in degree is 0.02932. So I'm gonna get the tangent of that. So that's gonna give me the value, and then times I multiply by A. So let me get to the value of A. So what was the value of A over here? A is 3.92. So I'm gonna multiply 3.92. So I have the answer here, very small, 0.002. So let me check my answer. So these are the correct answers. So similarly, you can work on the other problems and then try to use the equations I showed you. Alright, so I hope this is going to help you. So if you still have some questions, please feel free to write to me or call me. They give you the 3.6 parsec. The star is 3.6 parsec distance away, and then they are asking for the parallax angle in arcseconds. So I can show you the example, the equation here. So if you are looking for the angle in arcsecond, the parallax angle in arcsecond, you can just divide 1 over distance in parsec. Right here, you can see right here. So again, parallax angle in arcsecond should be equal to 1 over distance in parsec. Let's get back to the problem. So this is the 3.16. So you can simply divide 1 divided by 3.6. That should be your answer in arcsecond. 0.27777. Let me just keep that way. So, and they are asking for the angle in degrees. So how do you get the angles in degrees? You already have the angle in arcsecond. Then how do you get the angle in degrees? Do you remember? You divide by 3600. Divide by 3600 to get to degrees. So that's going to be a very tiny number, 0.1234 zeros and 77. And you can check the answers. Obviously they are correct. Alright, so I hope this is going to help you. So let me explain how to work on the last two parts, calibration and measuring stellar parallax. First is calibration. You click the calibration, you can see the star not moving. So once you stop tracking by the telescope, the star will appear moving. So put the grids on and let the star move by stopping tracking by the telescope. So you can go slowly. So you observe, you can see the time here. So observe is any star start from here and then go all the way and here. What is the time when it ends here and what is the time when it appears here? And the difference is what we are interested in. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 grids. So 10 grids. So and then how long it takes to for a star to start from here and to get here. So once you have that, then you go over here and use the triangle, use the table here. So stars, time as star enters and time as star leaves, and transit time. So you can work for a few stars to get the average in milliseconds. So once you have the milliseconds, you divide by 1000 to get the time in seconds. Then next thing is to calculate the angle of the field of view. So remember, there are 10 grids. So the total angle of field of view going to be transit time in seconds, whatever you have here, by dividing the 1000, dividing by 1000 of this number goes here, and then 86,400 times 360. The reason is Earth rotates 360 degree in a day, so the 24 hour means 86,400 seconds. So using this equation, so you're going to get the angle in degrees, but you got to multiply by 3600 to get the angle in arc seconds. Here is shown here. So that angle, that answer should be in arc seconds. So remember, there are 10 grids, so the total angle, whatever you have, divided by 10 would be the angular width per division, or per division on the grid. So this is the number, very important, so you can use for the next exercise. So for example, to get measuring the stellar parallax, what you're going to do is you start the animation and then show the grid. So now find out how many grids the star passes through. That many grids times whatever the number you got here should be the angle we are looking for right now. Angle should be equal to change in the position measured in the grid division multiplied by arc seconds per grid division. This arc seconds per grid division is whatever the number you got here. By dividing A by 10, then this number goes here, and that's the change in position measured in grid division. Means, like for example, this star, let's say this star passes like 5 divisions, the number 5 goes in there. If it crosses like 5.5 division, then it's going to be 5.5 and so on. So once you have the angle in arc seconds, you gotta divide by 2, because note that the angle you measure between extreme position is twice the parallax angles. To get the parallax angle, whatever the angle you got, divide by 2. So, and once you get that, then you can check your results. You can plot the value here, parallax angle first, and you know how to get the parallax angle. The parallax angle is in arc seconds, so you know how to get the arc seconds to parsec, and then how to get to light year. So that was done in the previous exercise. So once you complete, then check your results. So I'm not asking you to do